We'll see about Huffman coding. So what is the need for Huffman coding? Usually Huffman coding is used for data compression, that is to reduce the size of the data. The data can be anything. It can be a music, or it can be a video, or it can be simply a text, or it can be even an image. So to reduce the amount of data that it consumes, I mean the memory it consumes, we are using this Huffman coding. So using this Huffman coding, you can compress the data. So why to compress the data? So if you compress the data, the transmission cost will be reduced. Okay, so we are compressing the data, and one more thing is the efficiency will also be increased. Okay, so and the redundancy will be very much decreased. Okay, so the redundant extra values will be reduced. Since redundancy is reduced, it is also called as minimum redundancy code or optimum code. So this is the need for Huffman coding. So let us see the algorithm of Huffman coding. So these are the various steps that is involved in the Huffman coding. Okay. So next we are going to see the problem. So in that problem, we'll see how these algorithm is applied. So there are 6 steps actually. The very first step is you have to arrange all the probabilities in the decreasing order. Okay. So you have to arrange all the source symbols or your messages in the decreasing probability order, or otherwise descending order. The second algorithm is to you have to split the source symbols or your messages. Okay, so this has to be done in an orderly fashion. The lowermost probability are chosen first, and they are assigned, or they are split first, and they are assigned as 0 and 1. Okay, so then these two source symbols has to be combined. Okay, they have to be added up. Okay, and written as a new probability. Then you have to find the lowest two more source symbols or messages. Then you have to combine it. Then you have to do this step again and again till you have only two symbols. Okay, so for all these you will have a code word, and these code words can be traced using backward approach, not forward approach. Okay, so you have to trace the code word using forward approach method, and you have to write the code word in the backward approach. So that we will see it in this problem. Okay, so let us go into the problem. So this is the question. In a communication system, a source transmits 5 different messages, say x1, x2, x3, x4, and x5. You can name it as in any way. You can say it as a1, a2, a3, a4, a5. So it is your choice. So which has the probabilities of 0 0.3, 0.15, 0.25, 0.05, 0.25 respectively. And the question is, find the code word for each message and coding efficiency by applying Huffman coding method. Okay. So they have given you 5 different messages with their corresponding probabilities. Okay. And the question they have asked is, they have asked you to find the code word and the efficiency. Okay. I mean the coding efficiency, and that too you have to use Huffman coding method. Okay. So the first and foremost step of any problem is to write the given data. So you just write the given data, I mean the different messages and its corresponding probabilities, right? So these messages x1, x2, x3, x4, x5 and its corresponding probabilities are given here. So the next step is to arrange these probabilities in the descending order, that is in the decreasing order of probabilities. As you can see in the probabilities, there are 5 different probabilities. The highest probability or the greatest number among these 5 numbers is 0.3. Okay, then comes 0.25, but you can see there are two 0.25s. Okay, so 0.25 is repeated twice, and 0.15 is there, and 0.05. So this is the decreasing order. Okay, and one more thing you have to note, when you add all these probabilities, it should come as 1. Okay, so the sum of all probabilities should be 1. You can check it. Even if it is not 1, maybe in some cases the probability, the sum of probability will not be 1. So that may be an error. Okay, so you can even proceed with that, mention it as an error. Okay. So the probabilities are arranged in a decreasing order, as you can see with this corresponding message. Okay, so the next step is to splitting phase. The lowest two probability are grouped together and assigned as 0 and 1. So the lowest probability 0.15 and 0.05 are assigned 0 and 1 respectively. So then you have to add this, you have to sum this. So when you sum this, what you will get? 0.15 plus 0.05, you will get 0.2. So this is your first reduction. You have to combine the lowest two probability x2 and x4 and you have to write it as 0.2. So this is your first reduction. Then you have to check whether all the numbers are in descending order. So the first probability is 0.3, then comes your 0.25, then 0.25, then 0.2. So everything is correct. So you can proceed to the next step. So what will be the next step? You have to repeat this again. So the lowest two probability is 0.25 and 0.2. So you have to group this and you have to add it and you have to assign 0 and 1. So I have assigned 0 and 1, I have grouped it and now I'm going to add it. So when you add it, what I'll get? I'll get 0.45. Okay. So but 0.45 is higher than 0.3. Okay, the number 0.45 is higher than 0.3. So what I have to do is I have to shift it to the first position. So I'll write 0.45 in first position, then 0.3 is shifted to the second position, then comes your 0.25 to the third position. So now again, you have to check whether it is in descending order. Yes, it is descending order. It is in descending order. So now what you have to do, you have to again group the last two probabilities. That is the last two, 0.3 and 0.25. Again, you have to assign 0 and 1 to it. Now you have to add it up. So when you add it up, what you will get? 0.55. So again, 0.55 is higher than 0.45. So you have to shift 0.55 into the first position and 0.45 into the second position. This will be your third reduction. So 0.55 is in the first position and 0.45 is in the second position. Okay, this is your second reduction. Then again, you have to group this. Okay, only you have two numbers, so no problem. You have to assign 0 and 1 to it. Now, if you add it, you get 1. That's all. So till you get 1, you have to do it. Okay, so when you add 0.55 and 0.45, you'll get 1. So at this stage, you can stop this. Now you have to trace the code words. Okay, as I already said, for tracing the code word, first you have to trace that message in the forward direction. Then you have to write the code words using the backward approach. So that is what it is explained here. From first you have to trace it from left to right. Then you have to write the code word using right to left. Okay. So for example, for the first message x1, what you have to do? You have to write the or you have to trace. So x1 message, that is the 0.3 probability. In the first reduction, it remains in the same position. Okay. In the second reduction, it goes to the second position, and in the third reduction, it again comes with the first position. And you have to note the corresponding code word 0 and 0. Now we have to write the code words in the backward approach. Since both the code words are 0 and 0, there is no harm in it. So in either way, it will be same. Okay. So now the second message, that is x3. So x3, if you trace it out, it is 0.25. The corresponding probability of message x3 is 0.25. In the first reduction, it stays in the same position. In the second reduction, it goes to the third position. And again, in the third reduction, it comes to the first position. Okay. So now we have to trace the code word in the backward approach. So the first term will be 0 and the second term will be 1. So this is the code word for x3. Okay. So next you have to write the code word for x5. So you have to trace it using forward approach, and you have to write the code word using the backward approach. So it is 1, 0. Okay. Similarly, you have to do it for x2. Okay. So 0.15 is the corresponding probability of x2. So it has the same position in the first reduction. It goes to the first position in the second reduction and comes to the second position in the third reduction. If you trace the code word using backward approach, you will get 1, 1 and 0. So finally, the code word for x4. Okay. So finally, the code word for x4, if you use the same procedure, you will get 1, 1, 1. Okay, so you have calculated or you have found out the code words for all the 5 messages. Okay, so now just frame another tabulation, write the message and its corresponding probability again in decreasing order and write its code word. Okay, so we have found out all the code words right from x1 to x5. So we can write all the code words here, and again you have to write the code length. Okay, so that is denoted by nk. The probability is denoted by pk, and the length of that code word is denoted by s as nk. For example, 00 you have the length as 2, and 10 you have 2, and 111 you have 3. Okay, so this is all about the sum. The next is, as they have already asked, they have asked you 2 questions. One is to find the code word and the other one is to find the efficiency. So now we have found out the code word. Next you are going to calculate the efficiency. So for calculating the efficiency, you need 2 things. One is entropy and the other one is average length of code word for each message. Okay, so that is denoted by L bar. So the formula is summation k is equal to 1 to n nk into pk. So what is nk here? Nk is nothing but the length of your code word. Okay, and what about pk? Pk is nothing but probability. Okay, probability is already given in the problem itself, and code word, I mean the length you have found now. Okay, so you have to multiply the corresponding length and its probability for all the messages, and you have to add it up together. Okay, so that gives your average length of code word. Okay, so if you calculate, you'll get the value as 2.2. So the next is entropy, which is denoted as h of x. So it is minus summation k is equal to 1 to n pk log to pk, log base to pk. Okay, so you have already know that pk is nothing but the probability. Okay, so you just multiply pk into log base to pk. Okay. So just expand it from n for k is equal to 1 to n, that is 1 to 5. Then you have to calculate the value. So if you find the value of entropy, that is h of x, you'll get 2.15. So using these two values, L and h of x, entropy, you are going to calculate the efficiency. Okay. So the efficiency formula is h of x divided by L bar. Okay. So h of x is your entropy and L bar is your average word length. So 2.15 divided by 2.22, you get 0.977. So efficiency is actually described in percentage. So you have to multiply it by 100, you will get 97.7 percentage. So the efficiency of this Huffman code, this particular message, has 97.7 percentage efficient. Okay.